Hi everyone, I'm Lin Clark and I make code cartoons. And today I'm going to walk you through the wilds of data handling in React, so how you handle state in your React application. And I call it the wilds because when you first look at the landscape, it can seem like it's an untamed profusion of different options for how to handle data. It's really hard to figure out when you're looking at it what you might want to use and why you might want to use it. But when you look closer, you'll see that there are three groupings of ways to do this, and they're actually easier to understand than you might think. So I want to go for a whirlwind tour through them so that you can have a better idea when you approach your next app why you might want to use any one of these. So the first of these was Flux. And I'm going to start with the kernel of the idea that Flux introduced that carries through to Redux and to Relay. And that's it. Don't worry if you don't understand it, because this whole project started because I couldn't understand it. But once you understand Flux, this diagram is very clear. Before explaining the diagram, I should explain the problem that Flux solves. So Flux and React both come out of Facebook, and they were developed side by side to address a certain set of problems. One really good example of this set of problems was the notification bug. How many people remember this? You know, a few years ago, you go on Facebook, and you'd be clicking around, and all of a sudden you'd see a notification for a new message, and you'd click the messages icon and look at your messages, and there's no new message. And so the notification goes away, and you start doing whatever you're doing again. And then all of a sudden it comes back. And you just keep going back and forth and back and forth and back in this cycle. This wasn't just a cycle for you, the user. It was also a cycle for the team at Facebook. You know, they'd fix it, it'd be resolved for a few weeks, and then all of a sudden it would come back again. So they wanted to fix this once and for all and end this cycle of unpredictability. When they looked at it more closely, they realized the source of the problems was the way that they were handling data. They had these models, and the models which held the data would pass the data to the views, which would present the data to the user, would format it in HTML for the user. The views also provided a user interface for the user to put data back into the system. So the views needed to communicate back to the model. They needed to update that data in the model. But sometimes when you made a change to one model, another model would need to update in response. So you had this communication between models too. So this starts to look kind of like an epic game of Pong. It's really hard to figure out where the ball is going to land. Throw in the fact that these updates could be triggered asynchronously. You know, you could have an update that comes in and kicks off two more that are happening concurrently. And that's kind of like taking a bag of ping pong balls and throwing it into your Pong game, like everything's bouncing all over everywhere, and it's incredibly hard to figure out where everything's going to land. So that brings us back to this diagram. That's what you'll find if you see the Flux docs. And this is the way that Facebook solved that problem of the ping pong balls just bouncing all over the place. It was with a unidirectional data flow. So you'll notice that this data flows from one thing to the other, and when it gets to the end, it starts back at the beginning. And you should also notice that the first thing there, the first thing that starts off this cycle is the action. That's going to become more important later. But if you don't understand what the parts do, I don't think this diagram, even though it shows you this unidirectional data flow, it doesn't give you a good mental model of what exactly is going on. And it certainly didn't help me. What did help me was thinking about all of the different parts of Flux as different characters working together to take on a certain task. So I want to introduce you to the characters that I have in my head, and hopefully that helps you understand Flux too. So the first of these is the action creator. And I think of the action creator as a telegraph operator. Basically, other characters come to the action creator with a change that they want to make, and they have the action creator format an action that represents that change. The action creator is the one that knows how the rest of the system, what language the rest of the system speaks, and it knows how to format these actions in a way that the rest of the system will understand them. Each change that a view wants to make, the action creator turns into an object that represents it. The object has a type, something like message created, message read, message delete, and a payload, which tells it what message to do this to, what the text of that message is. So you define the list of those types, like message create, and have a full list of all of the different possible actions in your system. So this is kind of nice because it provides an API. If a new developer comes onto your project, you just point them to this list of different actions in your system, and they can know all of the different things that your system does. So once the action creator formats this action, creates this object, then it passes it off to the dispatcher. And I think of the dispatcher as basically a switchboard operator. It's a big registry of callbacks. It lists all the stores. It has a list of all the stores that need to be updated whenever an action comes in. And so it will send those actions that come into it to all the stores, and it'll do it synchronously. It will actually not have different ping pong balls going at the same time. It'll make sure that all of the action goes through the stores before it triggers the next one. Now, the Flux dispatcher is different from dispatchers in other systems, and it is different in that the action is dispatched to every single store. In other systems, a lot of times the dispatcher will allow you to subscribe to a certain set of actions. So your store might say, I only want to hear about message create actions, and the dispatcher will only send it that kind of action. Flux sends all of the actions to the store, and it's the store's responsibility to say, hey, I don't really care about this one, or I'm going to make a change based on this type. So now we get to the store. I think of the store as an over-controlling bureaucrat. All state and state logic live on the store. And there are no setters. There's no way to get in and change the data in the store except for this action pipeline. So I think of it as, the store is basically saying, no, you're not going to touch this data. Only I can touch this data. And if you want to me to make any changes to it, you're going to have to go through the official channels. You're going to have to go through the action pipeline. Once the store has actually made its changes to the data, we get to the view. And we have a controller view and the view that's underneath the controller view. So the view is basically a presenter that just takes the data that is given and turns that into something that the user can understand, turns it into HTML. It renders the data that it gets from the store. The controller view is a little bit more aware of what's going on in the system. It basically acts as a middle manager between the store and the presenter. It fetches data from the store and gives it to the view underneath it to render. So those are the characters in Flux. Now let's take a look at how they all work together to make an application happen. And before they start doing their actual tasks, they need to initialize. They need to do some setup to start talking to each other. So we're going to start with the setup, and then we'll look at how the application works once it's set up. So to set up, the store will tell the dispatcher what callback to use. It'll say, hey, here's a callback. As soon as an action comes in, just let me know. And then the controller view will talk to the store and will say, hey, can you give me the state, whatever initial state you have, and I'm going to send that down to my views. And so the store sends the state, which the controller view sends down to the views below it to render. This is the initial render of the app. And then the controller view goes back up to the store and says, and if any updates come in, just let me know. And so gives the store a callback to call. So everybody knows how to talk to each other now. And now we can start actually having user interactions. So the user is going to update the middle number, set it to 10. And the view, which has received this user interaction, is going to go down to the action creator and say, hey, here's some information. Can you format an action for me and send it off to the dispatcher? So the action creator creates the action, gives it the action type, and formats the payload, and then sends it off to the dispatcher. And then the dispatcher feeds it into the store. And of course, this is where the store says, do I care about this? How do I change the data based on this action type? So then the store changes the data that it holds, and it lets the controller view know. And then the controller view says, OK, great, and asks the store to send down the new data. And then we'll pass it into the view below it to re-render. So that's Flux. It ended the cycle of unpredictability, and all rejoiced, and created 100 different implementations of it. And now we move on to Redux. Redux is a lot like Flux. It's just a couple of differences between Redux and Flux. But if Flux solved the problem of this But I think that this is a really good use case for illustrating the changes that he made. So he was seeing debugging techniques in other communities, like hot module reloading and time travel debugging, and he wanted to introduce or improve them in React. But before I get into that, I should probably explain what those two things are. So let's start with hot module reloading. Imagine that you're developing a to-do application, and this is your to-do list object. So you've added a few to-dos, eat, sleep, and you want to change the way that you're adding the to-dos because you've realized that as they are added to the bottom of the list, it's kind of hard to tell that you're adding new to-dos. You want to add them to the top of the list so that people can see the new to-do as it's coming in. Now, as you're testing this, think about changing this add to do function so that it adds it to the front instead of the back. How would you actually see that change happening? Once you've made the change to the code, how would you actually check in your app that it's working? Well, you'd have to reload this object. But when you reload the object, you lose the state that's on it. You lose all of those to-dos that you had added. But you can avoid this problem. And the way that you do that is by splitting up the object into two different objects, one that holds the state and one that holds the functionality that changes the state. So then you can reload the object that has the functionality that changes the state, but you don't have to reload the object that holds the state. So this helps you debug faster because you don't have to keep replicating the state every time you change, every time you fix a little thing in your functionality. Time travel debugging is kind of similar in what it handles. So with time travel debugging, let's start about thinking about how you step through to debug an app. So you start with initial state, and then you perform an action. And that equals a new state. Your application is in a different state after that action. And then you take another action and another action. What if your bug is happening between step 2 and step 3? Even though we have this hot module reloading, which will keep the state, you really need to step backwards in time in order to be able to test that between the second and third action that you're fixing whatever problem's there. What time travel debugging does is lets you do that. It lets you step backwards in time so that when you change your functionality, then you can perform that action again, and you don't have to do the first or the second one again. So what do you need to do in order to make time travel debugging work? Well, you need to get a snapshot of your state at each of these points. And how do you do that? Well, you can kind of see it already in the way that I've drawn this. You treat this as an equation, as a function. Your initial state comes in, and you add the action, but you don't change the initial state. You don't change that state object. You create a new state object. And you just keep an array of all of these state objects as they're going through. This is what people are talking about when they talk about immutability. It's the idea that you don't change the things that are coming into your function. And you don't change the object itself. You just take in some parameters and you output, you return. You use your return value to give your caller or the value that it needs. So Redux makes it possible to do both of these things, to do hot module reloading on stateful objects and to do time travel debugging. I'm not going to dive too deep into a detailed walkthrough of Redux because it mostly is like Flux. And I've written this all up. If you want to go into a deep dive of Redux, you can go to codecartoons.com to see that. I do want to point out two of the key differences, though. The first is the way that the store works. Instead of managing the logic, the store just holds on to the state. It has like this one state object, this single state tree. It has all of the state in the app, which it's holding on to. And then when an action comes in, it passes the state and the action off to another object. It passes that off to the reducer. And it's the reducer that figures out how the state needs to change in response to the action. So you'll remember, this is what we needed for hot module reloading. We needed to have an object that's holding on to the state and an object that's actually performing the changes on the state. And these reducers, they do something else too. They make copies. Instead of changing the state that's coming into them, they make copies of that state. And then they give that back to the store. And so the store just swaps out the state it's holding on to for the new state. There's another difference between Flux and Redux, and that's the way that the state is sent from the store to the view layer. So you know how in Flux we had the view layer letting the store know that it existed and that it needed to have these callbacks called. In Redux, there's something called the view layer binding, and this will take care of a lot of that plumbing for you. So it reduces the boilerplate a bit. So that's Redux. And now we move on to Relay. If you've been following along closely up until this point, you might have a question that you've been thinking about. Where's the cloud? Where does the interaction with the server happen? In Flux, there's not really an agreed upon set place to do that with the server. Even at Facebook, different teams would do this in different places. In Redux, there is one place which is recommended, middleware, but it still requires some extra code to wire it up. Relay connects you to the cloud, and it wires it all up for you without you having to put in too much extra work, at least on the client side. So let's look at how Relay connects your client up to the cloud. But first we should ask, what's in the cloud? In the case of an app like Facebook, it's a huge graph of data. And when I talk about graphs here, I'm talking about graphs like graph theory. So a whole bunch of things and relationships between those things. And these things, they'll be things like users and events, and the relationships will be things like friend or invited to. In graph theory, these are often called nodes. The things are nodes, and the relationships between them are edges. So you have this huge graph of things and relationships between them are nodes and edges. But when you're showing a page to an individual user, you don't care about this huge graph. You only care about a small section of this graph. And what Relay does is it makes the connection between that small section of the graph that you care about in the cloud and your copy of it in your local cache. It knows how to manage this for you because you declare in your components which bit of the graph each component cares about. So it knows exactly which bits of the graph to pull down. So let's compare this with the way that communication with the cloud usually happens in a lot of other apps. Not all other apps, but a lot of other apps. You'd make a request. Your app would make a request to the server. And you have a component tree. You have this avatar and bio component. You'll send up the request, and the server knows exactly what to deliver because it delivers the same thing. So it will deliver the name, location, and picture properties because that's the list of things that it knows it has to deliver. The problem is, if you need to add a new property to the avatar or the bio component, or if you rearrange things, if you remove the bio component, The server doesn't know about that. You actually have to make a change in the server code at the same time as you're changing the client code. So this is coupling. What Relay does, in contrast, is have the component say exactly what it needs. It says exactly the data that it needs in order to render. So the avatar would say, I need the picture. The bio says, I need the name and location. And then the parent pulls those together and sends that off as a query to the server. And the server prepares it on demand for the application. So it gets pulled down and sent out to the components. And it gets put in a local cache. When you have this kind of structure, it enables some really cool things. Having your component say exactly what data it corresponds to in the graph, it makes it possible to automatically do things like splitting up your query so that you can have a part that's delivered immediately and gets rendered to the user immediately, that creates that more responsive feeling, and a part that's deferred. And you send both those queries up at the same time. One will come down first, immediately, and will render out the component. The other will come down later. It will get merged into, the data will get merged into the little bit of the graph that you have in your local cache. And then it will be sent out to its component, and that will render. It also makes it possible for you to reduce the size of queries that you're sending up. So let's say you have your data in this local cache now, and you've gotten to another page, and you need to get a little bit more data in order to render this page. But you already have most of this data in your local cache, so you don't really need to download it again. So it will just Relay will just take out the bits of data that you have in your local cache, push up the query, and then when that comes down, it'll merge it into the graph, send it out to the component. And it doesn't just do this for data that you have in your local cache. It keeps track of pending queries and what parts of the graph those are pulling down. So queries that have gone off to the server but haven't come back yet. And it will remove those from the outgoing queries too. It also makes it really easy to sync any changes that you're making to the data in the browser back up to the server. It will even handle optimistic changes to the UI. So, assuming that you're going to be able to write this data to the cloud and updating the UI as if you were able to do it. Oops. So you send up this, let's say that you accepted an invite to an event. You send that up to the server. It makes the change in your local cache and actually displays it to the user. And then when the response comes back down, it might be an error, or it might not be, it'll handle that, whatever comes down. Now, I don't have enough time to go deeply into how Relay does this. As you'll see, there are a ton of characters involved here, and that's because Relay is doing so much more for you. It's actually a framework. As opposed to Flux and Redux, they're patterns for handling data. But Relay is a framework. I do want to point out the thread that ties it to the other two, though. And that is that state is changed using objects that represent that change. In Flux and Redux, you have the actions. In Relay, you have mutations that get passed around to make these changes. So that's Relay. If you want to dig deeper into it, I'm going to be publishing a series of posts that explain everything about Relay, starting next week. So you can follow Code Cartoons or sign up for the mailing list to get notification of that. So let's review these three, starting with Flux. So Flux addressed the unpredictability of data flowing through Facebook's apps. And the way it did it was with a unidirectional data flow. Views, asking action, creating action, having the action creator create actions, sending it off to the dispatcher, which sends it off to the stores, which change the state, and then let the view know that the state has been changed, and then the view requests the state and sends it down to the views. Redux built on this and just modified a few things by breaking out the state into its own, the state storage into its own object, and the functionality that changes that state into a different object, and also collecting snapshots of the state. And then Relay built on some of the same ideas as Flux, but made it possible for you to connect the section of the graph in the cloud that you care about to the local cache in the browser. Thanks very much for listening. I hope that was helpful. And if you want to learn more about any of this stuff, check out Code Cartoons. Thank you.